So let's continue. So let's try to square the column x minus p. So for that, remember that when we say squared, all we have to do is to multiply the value on itself. So negative 2.25 times negative 2.25, that's square. So for to make it short, I'll just simply drag it down. Alright? Next thing is to multiply x minus mean squared to its corresponding probability. Okay? So this is our last column. Right? Again. So for the x minus mean squared, it's in here in the column E, while p of x is in the column B. Okay, so all we have to do is to focus on column E and on column P. I mean B rather. So equal times 0.1. To make it simple or to make it fast, I'll just simply drag it down. Okay, so remember, to get the variance, all we have to do is to get the summation of this. When you say summation, you have to just simply sum it up. So variance is equal to, simply sum it up. There you go. And then to get the standard deviation, all we have to do is take the square root of the variance. So square root of the variance is this. Okay, as you can see, there are many digits after the decimal, so it would be okay if you just simply get 4 digits or like 2. So this would be our computation. Okay, so on average during the weekends, the store manager was able to sold like 3.25 items, or that is, since there's no such thing as 0.25 items, just simply round it down. Okay, now let's proceed with the topic. Okay, so let's have some introduction first about our main discussion for today. So the normal curve, sometimes called Gaussian curve, is named after Carl Friedrich Gauss. He was the first mathematician to make use of its properties. However, it was found out later that Abraham de Moivre was the one who introduced the equation of the curve of error, or the normal probability. So it was Gauss, and then, but later on they discovered Abraham de Moivre, the doings of Abraham. So a normal distribution is a distribution of a continuous random variables. As I have stated earlier, this is the counterpart of this discrete random variable, whose graph is a bell-shaped curve called normal curve. The mathematical equation for the normal curve distribution is this, the formula here. Now, I don't want you to be concerned on this. Like, for the rest of the discussion, we will not be using that. I just want you to be familiar what is the mathematical equation behind the continuous random variable graph or distribution. Okay? So here, there's a legend E. E is a universal constant that has a value of approximately 2.71828. Pi is 3.14 for 1592. The mean or the mu is the population mean, while the sigma refers to the population standard deviation. Okay? Well, x can take any value from negative infinity up to positive infinity, in between those two. Okay? So based on the equation of the normal curve, the appearance of the bell shape still depends on two values: the mean, the mu, and the standard deviation, sigma, of the distribution. So here, the ABC graphs are examples of the graph of a normal curve. So as you can see, A is taller